There are many programming languages. I myself have used C++, Java, MATLAB, Mathematica, JavaScript, and Fortran. And each language has its own strengths and shortcomings. The reason that Python is so popular, especially in the data science community, is that it is really a very efficient language. You can accomplish a lot of things in just a few lines of code. In fact, most of the time in fewer lines of codes than many other languages. This efficiency in the language itself allows the programmer to focus more on solving the practical problem. And because of this efficiency, the code is usually easier to read, debug, extend, and maintain. Another advantage of Python is that there is also a very large Python development community that is constantly supporting the development of various open source libraries. And by using those well-developed, well-tested libraries, we can significantly improve our coding efficiency. In order to get started, we will need a Python development environment. If you are using a Mac or the Linux operating system, it is very likely that you have Python installed already. Here I am on a Mac. I'm actually on a Mac. So if I open a terminal, I can just type Python. I can just type Python in my terminal. And press enter. And it's gonna bring me into this terminal console of Python. And then at this 3 angular brackets of the prompt of the Python, I can type any kind of a Python commands to interact with the Python interpreter. For example, if I type print, maybe it's better if I do this, if I move the lines. So here these 3 angular brackets just means that's the prompt of Python, and it's actually waiting for me to type any kind of commands to. And if I, so suppose I do a function call, I'm calling the print function with the string hello world as its input, right? And then after I finish typing the command, typing the function call, I can press return or enter on my keyboard. And then Python interpreter is going to take this line and try to execute it. And the result of the execution is going to be displayed right away. That's the string, displaying the string hello world. Right. So that's working inside of the terminal console of Python by just using the terminal that's provided by my operating system. And if you are on a Windows machine, you can try to find out if you have Python installed already by on the Windows machine you don't really have a terminal that looks like this, but you have a command window. Right? And you can also try to find out if Python is actually installed on your system. In practice, this kind of a terminal console is not really very good for writing lots of Python source codes and developing very complicated Python projects. So in practice, you would like to have a development environment that gives you better editors, that gives you a better environment for you to test codes, and for you to actually manage different kinds of external libraries and external packages that you may want to use in your own Python program or Python projects. So So I myself actually use a Python integrated development environment which called Spyder, right? And before we actually install that, let's try to exit the terminal console. You can exit the terminal console in two ways. One is by typing the function exit. That will bring you back into the operating system's terminal prompt. Another way of exiting the terminal console is by holding down the control key on your keyboard and then press D, which will also take you out of the terminal console. So if we would like to set up a comprehensive development environment with automatic package management and with a very nice integrated development environment, I myself would prefer to install and use an application that's called Anaconda. So if this is just a browser, if you just type Anaconda Python into the search window, you will be able to find its webpage, and it's actually the first one that pops up in the search window. And you can select. If you click on it, it's going to take you to this particular webpage. It's provided by a company that's called Continuum Analytics, and it gives you some kind of documentation about what is Anaconda. Here it's telling you it's a high-performance distribution package management portal to data science, and this Anaconda is basically just a bundle of the latest version of Python itself, together with some very widely used Python packages. And this Anaconda distribution allows for automatic update of those packages and the Python versions, and it provides you a very nice package management system that automatically updates your Python environment to the latest versions. And it's got installers for 3 different operating systems: Windows, Mac OS, and Linux. So if you are on a Windows operating system, you might want to click on this thing and then download the Windows installer. I am actually on a Mac, so I have downloaded this version. If you are on a Linux, you might want to select the Linux installer. Right? All those installers are actually quite easy to use. All you have to do is to download it and then click on it, double click on it, and then it's going to automatically start and to install everything for you. And it's a very easy process. And after the download finishes, you can just click on the installer. It will take you through a sequence of setup steps. Choose the directory where you want to install, and then install the latest version of Python, and also those widely used packages, those libraries. Here you can sort of see 2 different versions. One is called Python 3.6 version. The other one is called Python 2.7 version. So there are some differences between these 2 versions. In some cases, code written in this kind of Python 2.something version may not run properly on systems installed only with a Python 3.something version. It's possible, and there are some syntax differences, and there are different ways of doing things in Python 3.something and Python 2.something. So there are differences, and the Python 3.something is designed in a way that's not exactly backward compatible. So from Python 2.something to 3.something, there is a jump in terms of the language itself. So in my videos, I will just use Python 3. So the version that I have downloaded is Python 3.6. So in my videos, I will just use this version. And if you are using Python 2 point something, it's very probable that you are running Python 2.7. In fact, if I type Python in my operating system terminal, you will see the Python version, the default Python version that's installed by my operating system. It's actually 2.7.10. It's not a Python 3.6. This is the Python that comes with my operating system. It's a 2 point something version. So in my videos, I will primarily be using the Python that's installed by this Anaconda installer. So it will have a 3.6 version. And I will point out the areas of significant difference between Python 2 and Python 3 later on in my videos. If there is any kind of significant differences in the topic that I'm talking about, I will point out the differences. And after you have downloaded the installer and after you have went through the installation process, which is actually painless, which is relatively easy, very easy actually. After the installation finishes, you will get a new application, and the name of the application is called Anaconda Navigator. So on my navigation bar, on my toolbar, it's called Navigator, Anaconda Navigator. It's called Anaconda Navigator. You can, on a Mac, you can try to find this particular application by just typing the Spotlight search. The Anaconda Navigator. So it's going to give you this particular application, and you can just launch it. You can just launch this particular application. If you are on a Windows or on a Linux machine, you can also try to find this application that you just installed and launch it using the standard method for your operating system. And once you have launched this particular application, the Anaconda Navigator, you will see a screen that looks like that. This is inside of the Anaconda Navigator. You're gonna see some of the widely used packages. Right. So here you have iPython, Spyder, and some other packages. Right. So here RStudio, right. But RStudio hasn't been installed yet. So if you want to install it, you can click on install. But here, these three packages are already installed. These three packages are already installed by the Anaconda automatically, and you can sort of find the Spyder package here, and it gives you some kind of a explanation about what this package is about. It's a scientific Python development environment, powerful Python IDE. IDE means integrated development environment with advanced editing, interactive testing, debugging, and introspective features. Because it's already installed, so it has a button that's called launch. If you move your mouse over it, if you move your cursor over it, it's going to change color. You can just click on launch. If you click on launch, then it's going to give you this particular window. Then that's Spyder, and tells you it's running Python 3.6. And that's the IDE, that's the integrated development environment. Inside of this IDE, you have three large pane or large windows, basically. So this is the editor. This is the editor. It has syntax highlighting, so different kinds of source code are colored in different ways. We'll talk about that later on. Right? And then there's this window. And this window actually has three tabs underneath it. The first tab is called Variable Explorer. For now, it's empty. There's nothing in it. That's because we haven't actually defined any variables in our workspace memory yet. And later on, when we actually introduce define some variables, you're gonna see their values in this particular tab and in this area. And if you click on File Explorer, then it's gonna give you a navigation window throughout your file system. So you can go up, go forward, go up. You can actually basically navigate through your entire file system by using this window. And if you find something, for example, a piece of source code, you can double click on it, and then it's gonna open inside of this editor. And then you have the Help tab, which is gonna allow you to search the documentation that comes with this IDE. And if you are new to Spyder, there's a tutorial for you to actually read through. But in general, this environment is actually very easy to use. You don't really have to sort of go through an extensive training in order to actually use this IDE. And then you have another window, that's the console. That's the console. So you have 3 tabs in the console. History log is just going to show you all the commands or all the functions that you have actually typed or executed before. That's just the history log. And then you have 2 types of console. Python console is not really very different from that terminal console we have looked at. It's pretty similar. It's a pretty similar thing. But for the terminal console, it's running a Python version that comes with my operating system. But here it's Python 3.6.1. So this is just like a terminal console, but with the correct Python version that comes with Anaconda. And then you also have another console that's called iPython console. And iPython console is a console that's kind of improved. It's an improved interactive. It's some kind of a interactive Python console that allows you to also type commands into it. So here, if I type print hello world, it will also function just like the terminal console. But in addition to that, you can sort of see syntax highlighting here, and then there's other features that comes with this iPython console. It's an improved version of the console of the Python console. So it's actually encouraged to use the iPython console. In fact, if you look at the Python console, it is actually telling you this Python console is going to be removed in a later version of Spyder. So they are actually encouraging you to use the iPython console. It is actually a better console. And later on, when you actually execute the codes inside of your editor, the results of those executions are going to be displayed inside this console also. The editor allows you to write Python source code and save into text files. And we will primarily be working inside of this editor window. And once we have finished writing some codes, you have a button. This button is the run button. It allows you to run that source code that's inside of this text file that you are actually writing. And it's got a shortcut. It's F5. The keyboard shortcut is F5. So now let's talk about that's our integrated development environment, right? And now let's really talk about how to sort of write Python programs. We will get more familiar with all those buttons later on when we actually start to work on some codes. My own experience in learning a new programming language is that there are 2 things that I need to pay attention to. One is the so-called data structures. Data structure is a big name, but essentially it just means the containers used for storing information or data. The containers. And the other thing that I need to pay attention to is the kind of actions that can be applied on those containers or data structures. And for Python, the data structures are very rich. It's actually it can be very complicated. But we will start from some simple data structures or data types. We're gonna start with these 1, 2, 3, 4, 5 different data types: Boolean, integer, float, complex, and a string. In fact, a string is already quite complex actually, but nevertheless, let's just treat it as some kind of simple data structure, right? And there are more complex data structures. For example, lists, tuples, dictionaries, ordered dictionaries. Later on, you can define classes to actually organize your data types or data structures into a hierarchical form. But all those different kinds of data structures are pretty much just containers of different kinds of information. And the containers has bigger containers and small containers. Right? Bigger containers can contain other bigger containers. Right? And other bigger containers can contain smaller containers. So you have a hierarchy of nesting among containers. Right? So now let's start from these kind of containers. These containers are relatively small and easier to understand. And later on, once we understand these kind of basic data types, we can build on top of it more and more complex data types or data structures. So let's look at the Boolean. Let's look at the Boolean. For the Boolean type, there are only two possible values, true or false. So now let's try to define two Boolean variables. So B1, this equal means assignment. I'm assigning this Boolean value to this container that has the name of B1. So B1 is gonna store this Boolean value that's called true, and B2 is gonna store another Boolean value that's called false. So for Boolean types, there are only two possible values, either true or false. This T and this F must be capitalized. Otherwise, it's not going to recognize it. If I change it to small t or small f, so the editor is actually telling me there's something wrong by showing up these kind of orange triangles. It's telling me undefined name true, undefined name false. It's telling me something is wrong, right? Because true and false, if I do not capitalize the first letter, it does not mean a Boolean value. It actually means a variable name, right? And those two variables are not defined yet, right? So if I change it to capital T and capital false F, then both of them are actually internal Boolean values of Python. And these are not variable names. These are actually values, Boolean values. And if I actually click on the run button or press F5, click on it, then inside of the variable explorer, I can see my variable names, B1 and B2. I got two variable names, right? And then they have a type of bool, a size of 1, and the value for B1 it's true, and for B2 it's false. So later on, once we have more and more variables defined, this entire window is going to be populated with lots of numbers. So that's Boolean. That's Boolean. It's relatively easy, and internally Booleans are actually represented using plain integers. What exactly is the integer, right? What exactly is the integer? So here, every line that starts with a hash is a comment line. And comment lines are actually ignored by Python. Python doesn't actually consider a line that's starting with a hash as a executable line. It's gonna just skip it. Those comment lines, even though it's ignored by the Python interpreter, but it's actually very, very useful for documenting your codes so that other people can understand your codes better. So those comment lines are extremely important. Right? So here you also see a comment line here. Right? And this line, the first line is, even though it looks like a comment line to Python, right? But this is actually called a Shibian line. This is understood by the operating system. Right? So hash followed by an exclamation mark actually has special meaning to the operating system. So the operating system is going to try to sort of use this particular command. That's sort of the env command that's underneath the bin directory, underneath the user directory, to try to find Python 3, and then use Python 3 as the interpreter to actually convert all the lines that you are writing in the text file into some sort of executable binary code. And then here you have like 3 double quotes. So here hash means a single line comment. 3 double quotes actually means multiple line comment. So if you start a section with 3 double quotes, then you can write multiple lines. So here it's like 1 line, a second line, a third line. These 3 lines before the next 3 double quotes are all treated as comments. Right? So single line comment start with a hash. Multiple line comment starts with 3 double quotes and end with 3 double quotes. So that's sort of the convention for comment. Right? So now let's write another comment. That's integer. Right? So let's look at some examples of integers. So I can define an integer. Let's just call it 23. Right? And then I2 equals to I1 plus say 3. Right? So I can add 2 integers together, and then the result is still an integer. Right? And the usual arithmetic operations all apply. I3 equals to I2 subtract I1 plus 7. Right? I4 equals to I3 multiply I1. That's plus, that's minus, that's multiplication, right? And then once it comes to division, there are some complexities. Right? So let's run it first. So now we have some integers that's populated inside of my memory space. I1, I2, I3, I4. It's all integers. The type is all integers. And then they have the correct values for it. Right? And when it comes to division, there are some complexities. So suppose I divide I4 by I1. Then what's going to be the result, right? If I divide I4 by I1. So I4 equals to I3 multiply I1, right? And I3 is an integer. So this division should give me an integer. In principle, right? Theoretically, it should give me an integer. Right? But in fact, it's going to give you a float. That's called F1. So F1 is actually going to be a float. If you don't believe me, just execute it. You will see it. F1 is actually a float. It's not an integer. Even though the result is 10.0, that's actually an integer, right? But it's going to be treated as a float. And this behavior is actually quite different from Python 2 something. So if you are used to the kind of behavior for Python 2 something, then let's give it a try, right? So I1 equals to 23. I2 equals to I1 plus 3. And then I3 equals to I2 subtract I1 plus 7. And then I4 equals to I3 multiply I1, right? So if I type I4 divide I1, then it's gonna, and let's still assign it back to F1, exactly the same code, right? And then what's gonna be the type of F1 in this Python 2.7.10? What's gonna be the type? You can find the type by using the type function, and it's gonna tell you the type is actually a int. It's not a float, it's an integer. So in Python 2.7 or 2 point something, integer division, an integer divided by another integer is going to return you an integer. But in Python 3 something, 3 point something, integer divided by integer is going to return a float. And there are consequences. The consequences is what? The consequences is when the division is not a whole division. So suppose F2 equals to I4 divided by I2, right? So I4 is not a multiple of I2. So this division is gonna evaluate to something that's not a whole number. So F2 actually is a float with this particular value, 8.8 something, 8.8 something, right? But if you actually evaluate the same expression inside of the Python 2 point something, then let's say F2 equals to I4 divide I2. And then let's look at the value of F2. So type of F2 is still a int. And the value inside of F2 is 8. It only took the number that's in front of the floating point, and everything that's behind it is actually ignored. So in Python 2 point something, the integer division is only gonna give you the whole number that's in front of the floating point. It's gonna ignore everything that's behind it. And that's sort of one of the important differences between Python 2 point something and 3 point something. And the default behavior in Python 3 point something is to actually make the division of two integers a floating point number, so it can actually account for all the numbers that's behind the floating point if the division is not a integer at all. But sometimes we might want to get this kind of an integer division behavior that's inside of the Python 2 point something. Right? If that's the case, how do you actually recover the kind of behavior, the default behavior in Python 2 point something, right? So I5 equals to I4, we use 2 slashes. If I5 equals to I4, 2 slashes I2, this 2 slash actually enforces a integer division with a result that's exactly identical to the result in Python 2 point something. So it's going to ignore everything that's behind the decimal point. So it's just not going to keep the integer part, 8. Right? So 2 slashes is going to force a integer division. And I5 is not going to be a float. It's going to be an int. It's going to be an int. So to get the remainder of the integer division, if we want to get the remainder of the integer division, we can use the modulo operator. So I6 equals to I4 modulo I2. That's going to give us the remainder. That's 22. The remainder of the division. And I6 is another integer. And in order to actually obtain the power of two integers, so suppose I7 equals to I7 equals to I1 power I2. So if we want to compute that, we can use two multiplications. So it means I1 to the power of I2. And this calculation is actually identical to using the internal POW function. POW function takes two input variables, I1 and I2. So if we actually do another calculation, you'll see that these two numbers are identical to each other. So by using this double asterisk, it's actually equivalent to typing this longer, slightly longer power function, using the power function. It's actually identical. And you can sort of see it's really a big number, right? These two integers are really big. They are really, really big integers, right? So what's actually the maximum integer that Python can actually represent, right? In Python 2 something, there are two types of integers. One is called int, and the other one is called long. So here, I1 is 23, right? And if you type the type of I1, it's a int, right? And if you want to convert I1 from int to long, there is an internal function that's called long. That's called AO1. AO1 equals to long I1. This way you can convert a 32-bit integer into a 64-bit integer. And then if you look at the type of AO1, it's going to tell you it's long. So long is has more precision than a int. So int is like 32-bit precision, but long has like 64-bit precision. So the maximum integer represented by long is going to be larger than the maximum integer that can be represented by int. In Python 3 something, there is no long type, and there is no long function. So if you try to type long I1, then it's going to give you the name long is not defined. There's no long function, and there's no long type. There's no long type. There is only one int type, and that int type is actually equivalent to the long type in Python 2 something. So in Python 3 something, every integer is a long integer. Is a long integer. So in Python 3 something, there is no long type anymore. There is no long integer anymore. There is just one int, and that int is represented at least by 64 bits, and it's actually system dependent, but it is at least 64 bits. The maximum integer that can be represented by Python can be found from a module that's called sys. So if I import, we'll talk about the import later on when we talk about the modules. But all you need to know for now is that sys is an internal module that comes with the Python language. And here, by using import sys, I'm actually bringing that module into my working environment. A module is just a collection of lots of variables and functions. So in Python 2 something, the maximum integer can be found by looking at one variable that's defined on the sys called maxInt, and then it's going to return the maximum number of integers that can be represented by a Python 2 something integer. And on Python 3 something, you can also find it. You can also find it from the sys module. Here I still have to import the sys. But the variable name is not maxInt anymore. It's called MaxSize. And that's this number. And both numbers are actually identical. So the maximum integer that can be represented by either Python 2 something or Python 3 something is this particular number on my system. The only difference is that in Python 2 point something, you have a distinction between an int and a long. But on Python 3 point something, it's all just the int. And this int is actually equivalent to the long in Python 2 point something. So that's a subtle difference, but we need to sort of keep in mind when we actually do numerical calculations. It's actually quite important. So now let's look at floats. Floating point numbers. The floating point type has, the float type in Python 3 and Python 2 has no difference at all actually. Both are implemented using the double type in the C language. So at least it has 64-bit precision. And the range of the Python float type can be found from the sys.float_info. And then it's going to print out the range of floats that can be represented by Python. And this information should be identical to my Python 2 point something installation. Float info. And indeed they are actually identical. Right. And floating point numbers also has the ordinary arithmetics. So I can actually so here I have two floating point numbers that's already defined, right? And I can do something about it. So ff1 equals to f1 plus f2, right? ff2 is going to be f1 subtract f2. ff3 is going to equal to f1 multiply f2. ff4 is going to equal to f1 divided by f2, right? So the ordinary arithmetic also applies. And if you want to sort of do power, ff5 equals to f1 star f2, right? So now you have a bunch of floating point numbers listed in here. So the ordinary arithmetic also applies. And that's float. And now let's talk about complex numbers. For scientific calculations, complex numbers are actually used quite often. So let's spend some time to talk about complex numbers. In fact, both Python 2 and Python 3 provide the complex data type. So both of them actually allows the use of complex numbers in Python programs. To define a complex number, there are two different ways of defining a complex number. We can either use the complex function, which takes two inputs, or we can just use the imaginary unit j to denote the imaginary part. So suppose C1 equals to, suppose we use the complex function. The complex function is going to take two arguments, the real part and an optional imaginary part. In fact, the real part is also optional actually. Right. So the real part and the imaginary part are going to be treated as floats. Even if you give it integers, it's going to be treated as floats. So if I give it two floating point numbers, f1 and f2. So that's one of the ways of defining a complex number. A second way of defining a complex number is to write it like this: 4 plus 3j, with no space between 3 and j. So 3j is going to be treated as a complex number, as an imaginary complex number by Python. So that's going to be the real part, and that's going to be the imaginary part. So you have two different ways of defining complex numbers. The imaginary part is actually optional, right? So if I neglect the imaginary part. Then the imaginary part are going to be treated as 0j. So it's going to be just a real number. So C1, C2, and C3, all of them are complex numbers, right? So C1 is defined using the complex function. And C3 is defined also using the complex function, but with F2 ignored. So now C3 has 10 plus 0j, but C1 has 10 plus 8.8 something j. And I was saying that, in fact, for the complex function, both arguments can be ignored. So if you do complex just with no arguments, then what's going to happen? Then you're going to get C4 that's exactly 0j. 0j is just a 0. Right? But the type is still complex. You're using C4, this complex number, to store 0. Right? Here you are using C3, the complex type, to store a real number 10, basically. Right? So the complex function takes not only just the floating point numbers, it also takes complex numbers. C5 equals to complex. Let's use C1 as the first input and C2 as the second input. So what exactly is C5, right? So it's going to use C1, this complex number, as the real part. So C5 is going to equal to, let me write a comment line here. C5 is going to equal to what? It's going to equal to C1 plus J, the imaginary unit, multiply C2. Or C2 multiply 1J. It's going to equal to that. Right? It's going to use this complex number as the real part, and then use this complex number as the imaginary part. And then you have to sort of do the calculation. And then collect the real part together. Then that's going to give you the real part of C5. And then collect the imaginary part together. And then that's going to be the imaginary part of C5. So if you don't believe me, you can define C6, C1 plus C2 times 1J. And C5 and C6 is supposed to be identical to each other. C5, that's this line, and C6, that's this line. That's exactly identical to each other. And for complex numbers, the arithmetics can be slightly more complicated, but Python can actually recognize it and do the correct thing. So C7 equals to C1 multiply C2. So that's gonna do complex number multiplication, which is actually similar to polynomial multiplication. And Python recognizes this multiplication as a complex multiplication, so it's gonna do the correct thing and produce the correct result. C8 is gonna equal to C1 divided by C2. Again, division is gonna be complex number division. And if you wanna take a power, you can do C7. Let me just do some arbitrary thing. So that's C7 to the power of C8, and both numbers are actually complex numbers. And if you evaluate them, C8, that's here, C9, that's here. Right. So that's the arithmetic of complex numbers. And for complex numbers, sometimes you would like to retrieve the real part and the imaginary parts of a complex number. And in this case, we can use this member function, data member of C4. So C4 is, if this kind of syntax, this dot syntax looks familiar to you, then you might have some background in object-oriented programming. Right? This dot is actually retrieving a data member in this C4 object. Right? So complex number in Python is actually defined as an object, is a class actually. It's a class. Okay, so you're actually looking at the data member of that class, of that object instantiated from the complex class. So here it's, and this .real is going to return a float. F4 equals to C4 dot imag. That's going to give you the imaginary part. So if you C4 is what? C4 is 0j. Maybe we should not use C4. Let's use a slightly more interesting number. Let's use C9. Let's use C9. So now F3 is supposed to be the real part of C9. That's minus 8897 point something. Minus 8897 point something. And then F4 is supposed to be the imaginary part. That's minus 52712 something. Minus 52712 something. Right, that's the real part and the imaginary part. And for complex numbers, sometimes we want to get the absolute value. It's called ABS C9. Let's not use C9. Let's use C2. C2 equals to 4 plus 3j. What's the absolute value of a complex number? 4 plus 3j, right? That's the absolute value is supposed to be 5, actually, right? It's the absolute value of a complex number is actually measuring the length. Is actually measuring the length of this particular vector in two-dimensional complex space. So the real part is 4. So horizontal axis is 4. And then the vertical axis is actually 3. So it's actually a right angle triangle. You have to take the longer side of that right angle triangle. If the two shorter sides is 4 and 3, then the longer side is supposed to be 5. So if I look at my F3, F4, F5, F5 is exactly 5. Right. So again, ABS actually recognizes its input as a complex number. If you just apply ABS to a real number, say F4, F4 is a real number, it's a float, and F4 has a negative minus sign in front of it. So ABS is just going to get rid of that minus sign. So that's F4, and then that's F6. They differ just by a minus sign. But for complex numbers, the ABS, the absolute value, is slightly more complicated, and Python actually knows how to do that, how to actually get the correct absolute value of a complex number. So that's also built into the Python programming environment, and it's very nice. It's very nice, especially for scientific computing. Complex numbers with this kind of precision and this kind of flexibility is very useful. And then now let's look at the string. Let's look at the string. String is already quite complex. It's a data type that's almost like an object with lots of member functions and member variables defined on it. So let's look at how we can actually use strings. It's actually quite flexible. You can define a string using either double quotes or single quotes. Hands-on start. So that's enclosing a string using double quotes. But I can also do something like that to Python. Right? You can also enclose a string with single quote, as long as you do not mismatch them. You cannot start with a single quote but end with a double quote. If that's the case, it's a syntax error, and Python is not going to recognize it. And in fact, the editor is telling you there's something wrong here. Right? So you have to sort of, if you start with the single quote, must end with a single quote. If you start with the double quote, must end with a double quote. And if we are actually using double quotes to enclose the entire string, then inside the string, we can use single quotes. Here, I have this thing. It's a single quote, right? But it's okay. It's okay if I am actually including the whole thing, the whole string inside of the double quotes. Then inside of the string, I can use single quotes, right? And if I just use one single quote without a second single quote to pair it, then this is called apostrophes. It's called apostrophe, right? And if we are using single quotes to enclose the entire string, then we can use double quotes inside it. Right? So the entire string is enclosed in a single quote. So inside of this string, I can use double quotes. So let's just run it and make sure that there's nothing wrong with it. So S1, S2, S3, S4, all of them are defined as a type of str string. So hands-on start to Python. One of Python's strengths, see the single quote here, right? And it has no problem with it. And Python is a language, not a snake. See the double quotes here, and it can recognize it all right without any kind of difficulty or error. We can concatenate strings together. So S5 is going to equal to S1 plus S2 plus version plus a space plus so this plus sign here, we have been using plus signs for numbers. Plus sign here, floating point numbers, complex numbers, integers, right? We have been using plus sign for numbers, but here plus sign are being used for strings. So the plus sign, the plus operator, is actually overloaded. When applied on numbers, it will do the arithmetic addition. And when applied on strings, it will do string concatenation. And when we are actually concatenating multiple strings together, we need to be careful not to mix the data types. That's one of the common error people often make. Right here, S1 is a string, str, right? S2 is also a string, so using a plus sign between them, that's okay. That's string concatenation. Plus another string, again concatenation. Plus another string with a space inside of the double quotes, but it's also treated as a string, right? Plus, if I get rid of the str, plus 1.0, then 1.0 is what? 1.0 is actually a float. So here, this plus is going to be confused because the stuff that's in front of it are all strings, but the stuff that's behind it is a float. So the plus sign is not overloaded for this kind of situation. It can overload number plus number. It can overload string plus string, but it cannot overload string plus number. And it looks like the editor is not actually catching this error. But if you run it, it's going to tell you something is wrong. Type error must be str, not float. So because 1.0 is treated as a float. And if that's the case, if you want to really concatenate the strings with numbers together, you must convert the number into a string by using the internal function called str. So str function is going to convert the number that goes into it into a string. So str 1.0 is going to return a string. This function is going to return a string. So now you're concatenating a string with a string. So now Python is going to take it. So hands-on start to Python version 1.0. It's like I missed a space here. We can easily change the case. We can easily change the case by using some methods. So suppose we want to change everything to uppercase, to capital case. Suppose we want to change everything to lowercase. All these are actually methods defined on the string object, upper, lower. And then if we want to change it to title case, so that the first letter of every word is capitalized. Right. Those are just the methods defined on the string object. And if we would like to separate a very long line of text into multiple lines, we can insert those escape characters into our string. So suppose S9 equals to simple data types. We can use \n to indicate a new line. If I do print S9, then it's going to display the string on multiple lines. Simple data types, boolean, integer, float, complex. Even though the string itself is defined on one line, but because of these escape characters, it's going to convert it when we actually do the actual print on the console, it's going to actually print it into multiple lines. So \n is going to create a new line for us. And suppose you want to format it, put some tabs in front of those smaller items, then you can use \t. \n, \t boolean. \n, \t integer. \n, \t float. \n, \t string. And then if we print 10, then it's going to give you some kind of indentation. There's a tab in front of each of the items. Right, so it's giving you some kind of formatting. Right. Sometimes white spaces can be quite annoying. For example, for hands-on start, we have a white space in front and a white space in the back, right? So if we would like to actually get rid of those white spaces, we can strip those white spaces using some predefined types. So S1 dot. If I want to get rid of the white space on the right side of the string, it's called rstrip. And if I want to get rid of the white space on the left side, it's called SL1. It's called lstrip. And if I want to strip out the white spaces on both sides, then it's just a strip. It's not rstrip or lstrip. So that's stripping out the white space on the right side. So if I select the whole thing, it doesn't have stuff white space in the back. And then this is stripping out the white space on the left side. So there is still white space on the right side. And then this is stripping out the white space on both sides. And another useful utility is to split a longer string according to some kind of delimiter. By default, the split, if I do not give it any kind of argument, it's going to split using the white space as delimiter. So if I just do that, it's not gonna sort of split multiple words out of this particular string, right? But if I give it a input argument, for example, I want to split it using this dash, then it's gonna split using this dash. Let's just run it and see what's happening. So hands-on start. If I split using white space, the front white space and the back white space has been removed, but hands-on start is not going to be splitted into multiple words. Here, I'm splitting on using this as the delimiter. So hands-on start, they are separated into 3 different words. But the hands, there's a white space in front of it. And then for start, there is another white space behind it. So how do I actually combine both? So how do I actually get rid of the white space here and also split the entire sentence, entire string into like 3 different words, right? I can chain those methods together. So I'm going to do a strip first, and then that's going to return another string with the front and the back white spaces removed, right? And it's also a string. The strip function, the strip method is going to return a string. So I can invoke split on this return string using this dash as the separator or delimiter. And this way I can actually achieve my desired output. Hands-on start with no spaces and 3 words. So we can chain those methods calls together in just one line, and which is actually quite efficient.